In this example, we're going to focus only on finding the asymptotes, or rather the equations of the asymptotes for this rational function. So there are three types of asymptotes that we're going to study in this class. Vertical asymptotes, that's where the denominator is equal to 0 and the factor does not cancel in the numerator. Vertical asymptotes. Horizontal asymptotes. Horizontal asymptotes are determined by looking at the degree of the numerator and the degree of the denominator. And then finally, slant asymptotes, which are kind of a specific type of semi-horizontal asymptotes where we still look at the degree of the numerator and the degree of the denominator. So let's start with the vertical asymptotes. Before you jump into labeling any asymptotes, you should always double check to see, does this factor? So the numerator and the denominator. Check each of them. They do not factor, neither one of these factor over the rational numbers. If this were, say, x squared minus 4 or x squared minus 9, maybe we could use a difference of 2 squares, then we would factor it. But since it doesn't factor in the denominator, we're going to leave it. And same with the numerator, 5x squared minus 8. 5 and 8 share no common factors. So they're technically factorable, but not with rational numbers. They would be square roots or imaginary numbers, so we're going to leave these as they are. So for the vertical asymptotes, since nothing factors or cancels from the denominator, that's where we look at where x squared minus 3 might be equal to 0. Now, since this doesn't factor, I'm going to solve it by moving the 3 to the right-hand side and then taking the square root of each side, not forgetting my plus and minus. So I have x equals plus or minus the square root of 3 for my vertical asymptotes. So remember, x equals a constant is a vertical line. So these are our two vertical asymptotes. Okay, moving on to the horizontal asymptotes. So for the horizontal asymptotes, you want to check the degree of the numerator and the degree of the denominator. Now in this problem, since they both have a degree 2, a 5x to the 2 and an x to the 2, then our horizontal asymptotes would be at 5x squared over x squared. That's the most powerful set of terms in the numerator and the denominator. When you're squaring a variable, the constant at the end becomes negligible as x gets really, really big. So this minus 8 and this minus 3 won't affect our function so much the bigger that the x values get. So we just look at 5x squared over x squared, which reduces really nicely to just 5. So our horizontal asymptote is at y equals 5. And remember that, and I'll label this as our vertical asymptotes, that is a horizontal line. It's a y equals line, which is a horizontal line. Now in this problem, there are no slant asymptotes. Those are where the degree of the numerator isn't the same as that of the denominator. Rather, the degree of the numerator is 1 more than the degree of the denominator. So if it had been maybe like 5x squared minus 8 over x minus 3, and this were a 2, this were a 1, then we would have a slant asymptote, and we would use long division of polynomials to figure out the equation of that slant asymptote. But that doesn't happen in this case. So I'm going to erase that so it doesn't confuse us, because that wasn't our question. We did have a squared in the denominator. Cool. So we have two vertical asymptotes, x equals plus the square root of 3 and x equals minus the square root of 3. And we have one horizontal asymptote.